All right, so today we're diving into resilient systems.
Oh, yeah. That's
And
gonna be fun.
it's a big topic.
It is a lot to unpack.
But it's more than just keeping systems up and running.
Yeah.
It's really about making them adapt and recover.
Right. And being able to kind of roll with the punches a little
Yeah,
bit.
fast forward. Yeah, learn from those disruptions.
Yeah.
So,
Yes. True.
so how do we even get here?
Yeah.
Like, where did this idea come from?
Yeah. So I mean it's kind of an evolution,
Oh,
Early on it was all about, fault tolerance.
mm,
If you have redundant hardware,
right.
if one piece fails, then you have a backup.
Okay, so just like a safety net, but for technology?
Exactly. Exactly like a spare tire,
Right, never knew that.
But then it obviously went beyond that.
Okay,
And it moved into this idea of fault safety,
okay.
where it's not just about having a backup, it's about containing the damage from a failure.
Okay, so you're trying to prevent that single failure from cascading into complete disaster.
Exactly. Exactly.
Okay.
You know?
So first we focus on preventing it and then on containing it.
Right.
What came next?
So then the big jump, the big shift was to this idea of our stability.
Our stability.
Yeah, it's like adaptability on steroids.
Right.
You know what I mean?
Yeah.
It's not just about being able to handle a failure. It's about adapting and changing
Okay.
to the environment or the requirements.
Wow.
You know?
So from basic redundancy to like learning and adapting,
Right.
that's a huge leap.
It is. It is.
Where are we seeing this kind of technology being used today?
Oh, man, it's everywhere.
Yeah.
One of the cool examples I always think of is like UAVs,
UAVs.
unmanned aerial vehicles or drones.
Drones. Okay.
Yeah, so you can have a network of drones working together.
Mhm.
And if one of them loses connection or fails,
Right.
the whole network can reconfigure itself.
Wow.
It's pretty
It's
crazy.
like straight out of a sci-fi movie.
Yeah,
That's awesome.
it is really cool.
What other areas is it having an impact?
Well, I mean, you think about something like space exploration.
No.
You have these spacecraft
Right?
millions of miles away from Earth,
Yeah.
and they need to be able to control themselves.
Right.
They need to be able to diagnose and repair themselves.
Mm.
Or you think about something that's a little closer to home, like critical infrastructure,
Oh.
like power grids.
Yeah.
We need those to be able to adjust to changes in demand or failures in the system so they don't cause widespread blackouts.
So these resilient systems are mission critical in a lot of areas.
They are.
But how do we actually build these things?
Yeah.
What are the building blocks?
So one key ingredient is something called software-defined networking, or SDN.
SDN.
Yeah.
Okay, what's that?
So it's essentially a way to make networks more flexible and programmable.
Okay.
Instead of being limited by fixed hardware,
Yeah.
SDN uses software
Right.
to control how the network behaves.
So you're giving the network like a brain that can make decisions.
Exactly. It separates the control plane, which is like the brains of the operation, from the data plane,
Mm-hmm.
which handles the actual traffic.
Right.
And this allows the network to make adjustments
Okay.
in real time based on what's happening.
That's incredible. But I imagine applying that to a UAV network
Right.
has to be pretty challenging.
Yeah, UAVs are constantly moving, which
Yeah.
means that the network is constantly changing.
Yeah.
Trying to maintain stability and security in that kind of environment is a big challenge.
Yeah, I bet.
Yeah.
So that's just one example.
Right.
What other kinds of technological roadblocks are we running into?
Well, one of the big ones we're working on right now is how to incorporate blockchain technology.
Blockchain, like
yeah.
the cryptocurrency thing.
Yeah, exactly.
What does that have to do with drones?
It's all about creating trust and eliminating single points of failure.
Okay.
So blockchain allows for this thing called a decentralized control system,
Okay.
which means that even if one controller is compromised, the others can keep the network running.
Got it.
It adds a whole layer of security.
So it's like a backup for the backup.
Exactly, yeah.
I can imagine trying to adapt blockchain to like a UAV network. Has to be a real headache.
It is a constant balancing act.
Yeah.
And you know what they say,
With that
with increased complexity comes.
human error.
You got it.
Don't tell me that these super smart systems are vulnerable to us messing things up.
They are.
Oh, no.
We can design the most resilient system in the world.
Yeah.
But if human error comes into play,
Right.
it can all fall apart.
Oh, man. That's scary.
It is.
So that brings us to a pretty important part of building these systems, human systems integration, or HSI.
Right.
HSI.
Okay.
I'm intrigued. What is that all about?
Yeah, so HSI is all about acknowledging that humans are part of the system.
Okay.
We need to design these systems with that in mind.
Yeah.
We need to minimize the risk of human error and make sure that people can interact with these complex systems safely and effectively.
So it's kind of like designing a car with safety features,
Yeah,
but for like power grids and UAV networks.
that's a great analogy.
Okay.
It's about understanding how people think, how they process information, how they make decisions,
Right.
especially under pressure,
Mm.
because even a minor slip up can have major
I
consequences.
can only imagine.
Yeah,
So how do we avoid those slip-ups?
right.
How do you actually bake good HSI into these systems?
So it starts with understanding the 9 key areas of HSI.
9.
Yes.
Okay, lay it on me.
All right, so we've got manpower personnel training, human factors, engineering, environment safety, occupational health, habitability, and survivability.
Wow, that's a mouthful.
It is.
Okay, so can you give me a quick rundown of what those areas actually cover?
Yeah, sure. So manpower, that's basically making sure you have the right number of people with the right skills to operate the system.
Yep.
Personnel is really focused on understanding the specific human characteristics and skills
Right.
that are needed for the system. And then training, of course, is making sure that those skills are developed
Right.
and that people are prepared to actually handle the system safely and effectively.
Okay, so that's making sure you have the right people for the job and they're well trained.
Right.
What about the system itself?
Mm-hmm.
How does HSI play into that?
So that's where human factors engineering comes in.
Yeah.
And that's all about applying what we know about human capabilities and limitations to
Right.
the actual design of the system.
So like making sure that the displays are easy to read,
Yeah,
the controls are intuitive,
exactly.
procedures are easy to follow.
Exactly. It's about designing systems that work with human nature and not against it.
Right.
And then you have to think about the environment that the system will be operating in.
Okay.
Extreme temperatures, high stress situations,
Mhm.
all of that needs to be considered.
Because a system that works perfectly in a lab might fall apart in the real world.
Exactly.
Yep.
You got it. And then there are the big ones, safety, occupational health, survivability, minimizing risks, protecting the well-being of the operators,
Right.
designing systems that can withstand attacks or other threats.
Okay.
Those are all crucial aspects of HSI.
It sounds like HSI is a pretty massive undertaking,
It is.
but absolutely crucial to making these resilient systems work in the real world.
It is. It's super important.
Are there any real-world examples
Oh, yeah.
of what can happen when HSI is overlooked?
Unfortunately, yes.
Okay.
Remember the grounding of the F-22 Raptor fleet back in 2011?
That rings a bell. Wasn't there some concern about pilots experiencing hypoxia-like symptoms?
Exactly.
Okay.
Turns out there was a problem with the onboard oxygen generation system.
Mhm.
It didn't have a proper backup, and some critical safety features were actually removed to reduce weight.
So a classic case of prioritizing technological performance over human safety.
Yeah, you could say that.
And the consequences were significant.
They were.
I mean, that grounding cost millions of dollars.
Yeah.
It really highlighted how important HSI is.
It did. It did.
What other examples come to mind?
Another one is the surprisingly high rate of mishaps with unmanned aircraft systems or drones.
Drones.
Yeah.
But I thought those were supposed to be safer than manned aircraft because they're controlled remotely.
That's a common misconception.
Okay.
Studies have shown that unmanned aircraft actually have a higher mishap rate.
Really?
Yep.
Why is that? I thought human error wouldn't be as much of a factor.
It's not that simple. Even though they're remote controlled, there's still a human operator in the loop.
Right.
And a lot of times those ground control stations aren't as user-friendly as they could be.
So you have these super advanced drones
Yeah.
being controlled with clunky interfaces.
It happens.
That sounds like a recipe for disaster.
It can be, that mismatch between the drone's sophistication
Yeah.
and the ground control station's usability.
Right.
That increases the risk of human error.
Makes sense.
It's a perfect example of how HSI needs to keep pace with rapid technological advancements.
Yeah, I mean, it makes you wonder if our concept of smartness needs to evolve when we're talking about these systems. Like,
Yeah.
what are we even aiming for when we say we want to build a smart system?
Yeah, that's a great point. We often talk about the machine intelligence quotient, or
Okay.
MIQ,
MIQ. Okay.
which basically measures a machine's intelligence
All right.
based on things like its autonomy, human-machine interaction, and its ability to handle complex situations.
So it's like an IQ test, but for machines.
Pretty much, yeah.
Okay.
But you're right. MIQ is still very machine-centric.
Yeah.
It doesn't fully capture the impact of these machines on humans and the environment.
That's a big piece of the puzzle.
It is.
So how do we account for that?
Well, that's where the idea of a smartness quotient, or SQ, comes into play.
Sick.
Yeah.
Is that like an upgraded version of MIQ?
You could say that.
Okay.
SQ takes a more holistic view. It considers not just the intelligence of the machine, but also its usability, its environmental impact,
Okay.
and its overall contribution to human well-being.
So it's not just about how smart the machine is, it's about how that smartness is applied in the real world.
Exactly.
Okay.
SESQ factors in things like the usability index of machine, or UIOM, which measures how user-friendly a machine is.
Gotcha.
And it also considers the environmental performance index of a machine, or EPOM, which looks at its environmental footprint throughout its entire life cycle.
So from the materials used to build it,
Right.
to how much energy it consumes, to how it's disposed of.
All of that.
That's incredibly comprehensive.
It is.
Oh.
SQ is all about taking a more responsible and sustainable approach to building intelligent machines.
Okay.
It's not just about building smarter machines. It's about building machines that make the world a better place.
It sounds like SQ is a really powerful concept, but how do we actually measure it?
That's a great question.
What are the benchmarks?
And that's one that researchers are still actively exploring. Okay.
There's no single universally accepted way to measure SQ just yet.
So it's still a bit of a moving target.
It is, but that's part of what makes it so exciting.
Right.
We're still figuring out what smartness really means in the context of these systems
Yeah.
and how to quantify it in a meaningful way.
It's certainly a challenge worth tackling.
It is.
This has been an incredibly eye-opening conversation.
It has.
We've covered so much ground, from the evolution of resilient systems and the importance of HSI to this emerging concept of SQ.
Yeah, it's a lot to unpack.
I feel like we've only scratched the surface.
And that's the beauty of it.
Yeah.
Building resilient systems is this ongoing journey of exploration and innovation.
Right.
There's always more to learn and more ways to improve.
So where do we go from here? What's
Yeah.
the next frontier in this field?
Well, I think a major focus is going to be on how we can use these ideas of smartness and SKU to create even more resilient systems in the future.
Okay.
Systems that not only adapt and survive, but thrive.
Right. And contribute to a better world.
Systems that are not only smart, but wise.
Exactly.
I love that.
We need to go beyond simply creating systems that can withstand disruptions
Yeah.
and start thinking about how they can actually improve our lives and make our world more sustainable.
That's a challenge worth taking on.
It is.
Thanks for taking us on this deep dive into the world of resilient systems.
Of course.
It's given me a lot to think about.
It's a fascinating topic.
Yeah, it really does feel like a paradigm shift
It is.
in how we think about and build these systems.
Yeah.
You know, moving from just resilience to a kind of smart resilience that has a bigger impact.
Yeah, definitely. And, as we develop these frameworks for measuring SISQ,
Right.
it's going to bring up a lot of interesting questions.
Like what?
Well, imagine you're a consumer
Okay.
and you're trying to decide between two products. They have the same features, the same performance,
All right.
but one has a much higher SISQ rating.
Okay.
How much weight would you give that?
That's a good question.
Yeah.
It's like choosing between a product that's just smart and one that's smart and responsible.
Exactly.
Yeah.
And, as consumers become more aware of ESQ and what it means, it could really drive demand for products and systems that not only function well,
Yeah.
but have a positive impact.
It'd be like a sustainability seal of approval,
Yeah,
but for smartness.
I like that.
Yeah.
And it's not just consumers.
Right.
Think about the companies that are designing these products.
Okay.
If they know that a higher ESQ rating can give them a competitive edge,
Yeah.
that could lead to a whole wave of innovation
Right.
focused on creating systems that are not only resilient, but also user-friendly, energy-efficient, ethically sourced.
So we're moving from a culture of just building things
Yeah.
to a culture of building things better.
Exactly.
And that could have huge implications
It could.
for everything.
Yeah.
I mean, from the products we buy to the infrastructure to the way we explore space.
They really could, yeah.
It feels like we're on the cusp of something really big.
We are.
And the best part is this is just the beginning.
Yeah.
I mean, as our understanding of smartness evolves and we develop more ways to measure and evaluate it,
Right.
who knows what we'll be able to create.
Yeah. It's really exciting.
It is. It's exciting to be part of this.
It is.
Thanks for sharing all this with me today.
Oh, it's my pleasure.
This has been a truly fascinating conversation.
Yeah, I think it's important to have these conversations.
It helps us all move forward.
Definitely towards a more resilient and sustainable future.
Absolutely.